In this example, we're given that a sinusoidal voltage is V of t is equal to 300 times the cosine of 120 pi times t plus 30 degrees, given in volts. And then in part A, we're asked, what is the period of the voltage in milliseconds So we know from the lecture videos that we have an equation that omega, which is what we're given here, 120 pi, is equal to 2 pi over t. We can rearrange that a little bit to say that t is just equal to 2 pi over the frequency in radians per second, 2 pi over omega. So now we can go ahead and plug in our values. We have t is equal to 2 pi over 120 pi. We don't even really need a calculator for this first part. The pi's cancel. That's equal to 2 over 120, which is going to be equal to 1 over 60 seconds. Let's go ahead and put that in our calculator, and we'll get that t, our period, is equal to 16.667 milliseconds. So that's part A. Now, part B asks us, what is the frequency in Hertz? B is the frequency in Hertz. There's a couple of different ways we could solve this one, but fundamentally we just know that our frequency is equal to 1 over the period, and that's given in Hertz. Now we could do 1 over 16.667 times 10 to the negative third. We could also just say that since t is equal to 1 over 60 seconds, frequency is equal to 1 over 60 seconds. At 1 over 60 is just equal to a frequency equal to 60 hertz. Next up, part C asks us, what is the magnitude of the voltage at t equals 2.778 milliseconds. So let's start by plugging in what we've already got. We have an expression for our voltage, and let's say that V at t equals 2.778 milliseconds is going to be equal to 300 times the cosine of 120 pi times 2.778 times 10 to the negative 3 plus 30 degrees, and that's given in volts. Let's take it a step further. Let's say that's equal to 300 times the cosine. Now if we multiply 120 by 2.778 times 10 to the negative third, we're going to get that it's cosine of 0.333 pi plus 30 degrees in volts. Now we run into a problem that we talked about in the video. This first part is given to us in radians, and that of course is in degrees, so we need to do a conversion. Remember that our equation, we'll go ahead and convert the radians into degrees, but you could actually do it the other way around. But we'll say that our degrees is equal to 180 degrees over pi times the value in radians. Use a slightly different color for this. So we'll say our value in degrees is equal to 180 degrees over pi times 0.333 pi. pi's cancel, 180 degrees times 0.333 is equal to, so degrees is equal to, it's actually 59.94 degrees, but since, let's make the math a little bit easier, let's just round it up to 60 degrees. Now we're ready to come back to our equation. 300 times the cosine of now 60 degrees plus 30 degrees in volts is going to be equal to 300 times the cosine of 90 degrees in volts. And if you remember your unit circle, it's going to make this one pretty easy. We can say then that our voltage at T equals 2.778 milliseconds is simply equal to 0 volts, since the cosine of 90 degrees is 0. Finally, and simply, part D asks us what is the RMS value. Remember that equation for V RMS is just equal to the maximum amplitude of V over the square root of 2. So we can say that our V RMS is equal to 300 over the square root of 2. So dropping that into our calculator gets us that. Our final answer, V RMS, is equal to 212.13 volts. And that is it for this example. Just to recap really quick, we were given that we had a sinusoidal voltage of 300 cosine 120 pi t times, plus 30 degrees volts. First, we were asked to calculate the period of the voltage. We knew what our frequency in radians per second was. We knew it was 120 pi, so t is equal to 2 pi over omega. That gave us t equals 16.667 milliseconds. Then frequency in hertz, we used the fact that our original frequency in seconds was 1 over 60, so frequency is equal to 1 over t, so that's equal to 1 over 1 over 60, so our frequency is just equal to 60 hertz. Then we needed to calculate the magnitude of the voltage at t equals 2.778 milliseconds. We took our equation, we plugged in that value for t. We got the interesting part here is we got a value in radians, then plus degrees, so we had to convert the radians into degrees. Gave us a value of 90 degrees total, so cosine of 90 degrees is 0. So we got to the amplitude of that voltage at that time was equal to 0 volts. And then finally, we used that really simple RMS equation to calculate the RMS value of our voltage. So that's it for this one.